What role does the molecular interactions play in solution of alcohol and water? So when we say alcohol and water, you need to understand which type of mixture it forms on that basis, or if you can even understand that whether there will be any specific type of interaction. Yes, alcohol and water have hydrogen bonding. So the only point you need to write if it appears in 1 mark question, alcohol and water form hydrogen bond. Okay. That is the only thing. Otherwise, if it is suppose it is and it has appeared once or twice in 2 marks question, if it is asked about, then you will talk about hydrogen bond and you will give example and diagram also how it will happen. So for example, you will say CH3 CH2 OH will be there, and there HOH will be there, and there will be hydrogen bonding. Okay, there will be hydrogen bonding between oxygen of water molecule, so HOCH2 CH3. So there also, here also hydrogen bonding will be there. It can be any alcohol. Yes.
Sir, in this, sir, the solubility will decrease with the increase in molecular weight, right?
Right. So because hydrogen bond is there, remember hydrogen bond is there in alcohol as well. Hydrogen bond is in water also there, right? So you have to memorize. You have to memorize which type of interactions will be there. Okay. So that is another question. Basically, that is I will float the question to students, and then I will tell you whether it will be greater or lower. But that is a good question. Okay. But Samad, you have given good answer, correct, very good. Samad has already written that what I asked basically, and that is correct. So if these are mixed, whether the interactions will be stronger or weaker?
When we mix alcohol and water.
Yes, when we mix alcohol and water, and I am telling you there are hydrogen bond even before mixing. In alcohol, you have hydrogen bonding. In water, you have hydrogen bonding. But when you mix, yes, Pratham, correct. But when you mix alcohol and water, due to in decrease in symmetry, symmetry is decreased now, right? One is alcohol molecule. Sorry. One is alcohol molecule, the other one is water molecule, another one alcohol. So symmetry decreases. And you know what happens if symmetry decreases. If symmetry decreases, force of attraction will decrease. Yes, Pranav. Okay, Shashwat. Yes, Shashwat. Good. Okay. So the interactions between alcohol and water will be weaker. Alcohol, water, hydrogen bonding, or you can say interactions will be weaker. You will say though there will be hydrogen bonding, alcohol water interactions will be weaker than alcohol alcohol or water water interactions due to decrease in symmetry. So tell me whether it will be positive deviation or negative deviation. When interactions become weaker, whether it will be okay, Pritham, good. Yes, you can write in the chat box, everyone. Devyansh correct, Tanishi correct, but Ariman think again. Kasak, yes. Sab, yes. Okay, so the positive deviation, it will be positive deviation, and the reason is because the interactions become weaker. Okay, so as you can say, um, yes, correct. Okay. Most of the answers are correct. Okay, so as you will say, hydrogen bonding will be there. So I'm just repeating, hydrogen bonding will be there, but it will be weaker hydrogen bonding than alcohol or water due to decrease in symmetry. That's why it will be positive deviation. And it is when it is positive deviation. Tell me whether it is which type of azeotrope it could have been. It could have been, I'm saying, right? Anyone?
Can you read your question?
Right. Okay. So all of you are correct. So I'm not saying name because too many answers I received. Fine. So yes, minimum. Correct. Good. Now the next question. Why do gases always tend to be less soluble in liquids as the temperature is raised? When we raise the temperature, then, for example, carbon dioxide from the soda will come out. Why is it so? The answer you will be writing because when gases are dissolved in liquid, it is exothermic process. So first statement will be dissolution of gases in water. Okay, or specifically liquids here, don't say water. Liquids is an exothermic process. Dissolution means dissolving the gases, dissolving something. Pratham, yes. Okay. So because it is an exothermic process as per Le Chatelier's principle, what will happen? Just visualize it, don't write it, okay? A plus B gives you C plus D, and if it is exothermic, heat will be evolved. So it means if I increase the temperature, it will go into backward direction. So don't write this reaction like this. You can write if you want. There is no need. So if you even want to write this one, you will say liquid plus gas equals to solution plus heat. You will write it like this. Okay. So if you increase this heat, the reaction will go in backward direction. So as per Le Chatelier's principle, the reaction will go in backward direction on increasing the temperature. Hence, they become less soluble because question is talking about, okay, hence solubility of gases decreases on increasing the temperature. Ashwati, yes, correct. That is the answer here to be written. Good. And remember, don't try to memorize the steps or as it is what I am writing. If you understand, you just need to learn how to write it. So if you remember, only then you will be able to write it. So it is better you understand it instead of cramming it. Next one. States Henry's law and mention some important applications of it. So when you write the Henry's law, first write this statement. The mass of a gas dissolved per unit volume of the solvent at a constant temperature, you are not changing the temperature, otherwise the amount will change, is directly proportional to the pressure of the gas in equilibrium with the solution. Obviously, you will write it just because you know the equation, you know the formula. Based on that, you will say. Vedant, that is the application. Yes, I will be talking about one. There are 4 total applications you need to remember. First, we are talking about the definition. Okay, so the definition here is this one, and I will be writing exactly as per this formula also. We say the mass of a gas means the amount we are talking about. The amount of a gas dissolved per unit volume of the solvent means within the solution is directly proportional to the pressure. So what I am saying, if this is the bottle of soda or Coke, okay. So whatever mass of gas is here, it is proportional to this pressure. This mass of gas in the solution, okay, is proportional to the pressure above it, pressure of the gas. Yes, those are 2 applications. So with this formula, we can directly write it. We can say that is the partial pressure of the gas in vapor phase is directly proportional to, because it is actually P is proportional to chi or X to mole fraction. So this is mole fraction. Obviously here I have introduced the constant, so that's why we have removed the proportionality. This actually means P is proportional to X. That's what you are writing here. Partial pressure is proportional to mole fraction. Obviously, you need to say constant temperature again. I have not written here. Temperature cannot change. Then the applications, if we talk about, there are 4 applications you need to remember. First is in production of carbonated beverages, okay, Coke, Pepsi, etc. Then in deep sea diving, scuba diving, what happens that due to pressure, a lot of nitrogen gets mixed with the blood of the scuba divers. So because that nitrogen gets dissolved when they come to the top, pressure decreases rapidly, and this nitrogen comes out from the blood in the form of bubbles. So it forms bubbles, that is fizz, what you see in Coke, Pepsi, etc. Fizz, bubbles. Those type of bubbles of nitrogen are found within the blood, and it can be life-threatening. It can be life-threatening. So what is done? Helium is mixed. Some helium is mixed with the air so that not all nitrogen gets mixed. Less nitrogen gets mixed in the blood. Yes, Ariman, that is the next one I'm going to talk about. So is this part clear or not? Blood plus nitrogen is dangerous condition, because when nitrogen comes out of the blood very rapidly, first it is dissolved in the blood, and then it is not in the form of bubbles, but when it comes out in the form of fizz, what you see in Coke and Pepsi, and that fizz causes problem in the bloodstream, can be life-threatening. So what is done is, along with nitrogen, there is some helium also mixed, and helium.
Sir, helium and liquid helium dissolved with the warm air.
Yes, so that's how it is dissolved. That is the process, but you can skip that. You can simply say that helium is also mixed with the air so that less nitrogen gets dissolved in the blood. Next one, at high altitudes. When we talk about at high altitudes, pressure is low there. So if you have, for example, ink pen, fountain ink pen, here in Delhi or Chennai or Mumbai, and you go to Himalayas, for example, there will be less pressure outside, and the solubility will decrease. The solubility, because outside pressure is low. As I said, outside pressure, here suppose I talk about this one, Here, this is suppose pressure inside pen, and this is outside pressure 1 atm. But on mountains, this 1 atm will be less than 1 atm. The pressure will be less than 1 atm, and the ink will come out of the pen. Pressure will decrease. So at high altitude that happens, and you might have seen if you take these chips packets etc. from here to say Manali, Shimla etc., you will see that those are puffed there, means those are swollen. The reason is very simple, because the pressure outside is less. So that's why. Then in the function of lungs, also in the function of lungs means when we say we respire, actually the air gets mixed in the blood. So air gets mixed in the blood due to the atmospheric pressure outside. Okay. So again, same thing is happening. The pressure outside forces the air to get mixed with blood in the lungs. So you need to write these 4 applications also. Then the next question here is,
Can you show the previous page?
yes. However, I would suggest that don't write everything what I am telling you. You can anyway refer to the videos. At this point of time, try to memorize, try to remember, try to understand what I am saying. Otherwise, you might face problem later on. Okay, so you need to change your approach. Don't note down everything. Only the key points you need to note down. Okay. Next one, the partial pressure of ethane over a solution containing 6.56 into 10 power minus 3 grams of ethane is 1 bar. So solution contains this much ethane, but the pressure above it is 1 bar. If the solution contains this much, so within the solution, this much ethane, just let me, yes. So if the solution contains this much ethane, then what shall be the partial pressure? Think about it. Question is very easy, basically. This type of question we have
So we
done.
would have to take out the mole fraction in this question.
Come again.
So do we have to take the mole fraction in this question also?
Mole fraction, you have to, but think in terms of Henry's law. Pratham, yes. Tanishi.
Sir, the values which are given right here, they are the values of the Henry's constant.
No. Partial pressure is given and amount of ethane is given. Prakriti, yes, that is what you need to do. Kasak, yes, good. Pranav, yes, correct answer. Okay, so how do we do that? Basically, KH is not given. You have to get the answer first, equations in terms of KH, and then get the answer. Okay, so you know that partial pressure is equal to KHX, and you don't know what is KH for ethane. It is not given here. But what is given is the amount and pressure. In one case, it is given that the partial pressure is P1, 6.56 into 10 to the power minus 3. No, sorry, amount. This is the amount. P1 is 1 bar. And W1 amount is given 6.56 into 10 power minus.
Sir, we can also use that the mole fraction of ethane will be directly proportional to its mass.
That's what we are saying. Okay, you can say, but that is exactly the same thing. Just the writing is different. Okay, this is actually P is proportional to X. When you remove the proportionality constant, you introduce it. Okay, so it is same thing. Here I will divide, it will get cancelled. That's why I'm using it. Then P2 is asked and W2 is given 5 into 10 to the power minus 2. It is given. So what you will do now? With this one, with this information, what you can do? Remember here P2, W2, here W2 does not mean the mass of solvent or solute, or W1 mass of solvent or solute. No. This is one case, this is second case for the same. So what we can do now? Right. So if you write the equations now, so it will be P1 equals to KH X1 and P2 equals to KH X2. And X1 and X2, how can you get? How can you get X1 and X2? Can you get X1 and X2 in this case? If yes, how?
The partial pressure would be same, sir.
No, partial pressure cannot be same. Partial pressure is asked. It cannot be same. Okay, anyone? There is another way also, I'm telling you in advance. There is another way also when we use different form of Henry's law. But I am asking, if I use this form of Henry's law, will you be able to get the answer? If yes, how? Prakriti, Yash Bedi, are you there? Pratham, Devyansh,
Sir, may I?
yes, you can.
Sir, so we'll just find the ratio of P1 upon P2,
Okay.
and then sir, we can, in this case, we can neglect the amount of ethane in, when we calculate the mole fraction, we can neglect the amount of ethane in the denominator because it is almost negligible.
Okay.
So then, sir, KH will cancel out, and the number of moles of water in both cases would cancel out. So then we can find the answer.
You are absolutely fine. Just don't say water because it is not mentioned here.
Yes, sir.
So
All right.
yeah. So basically that is the approach you have to do. You will say that the amount of ethane is negligible. Okay. It is negligible 10 power minus 3. So it is negligible. So that's why you can neglect the number of moles of solute as compared to the solvent. So you can say mole fraction, that is X1, will be given mass divided by molar mass. Okay, sorry, N1. N1 will be given mass and its molar mass. So you write M only, right? Molar mass. Don't write molar mass because it will get cancelled. Is this clear or not? Number of moles in first case of ethane, number of moles of ethane in first case will be given mass divided by its molar mass. And N2, that is in this case, it is not, I'm not writing right. I'm just changing these so that there is no confusion. I'm writing P dash and X dash. Okay? So N in first case is W. Divided by M, and N dash will be W dash divided by M. Is that clear or not, everyone? Just try to understand what I am saying. In first case, mass is given 6.56 into 10 power minus 3 divided by molecular mass. That will give you number of moles. In second case, mass is given this much divided by its molar mass will give you number of moles. But this X will be N divided by N plus N dash. This we will say it is approximately equal to N divided by N divided by N dash. Basically the same thing. What is there with the ratio will remain same. So whatever is the ratio of the masses, the same will be the ratio of. So what you will say, suppose it is not n dash, basically I had written. In first case, it will be x divided by n divided by whatever is the number of moles of solvent, that will be, say it is ns. Okay, in second case, it will be n dash divided by ns. Right, if there is any confusion, I will write both separately. Okay, so just I am writing both separately so that you can understand in one case and in second case what I am talking about. There might be some confusion. I am just writing first case, second case. In first case, the mass given is 6.56 into 10 to the power minus 3 grams. In second case, it is 5.00 into 10 to the power minus 2 grams. Right. Molar mass I am keeping same. Okay, so I'm not talking about that. In case, first case, pressure is 1 bar. In second case, pressure is required, what we need to calculate. Okay, if I calculate number of moles here will be 6.56 into 10 to the power minus 3 divided by m, given mass divided by molar mass. Here it will be n dash 5.00 into 10 power minus 2 divided by m. Molar mass of ethane is same, it is not changed. Now suppose I talk about the number of moles of the solvent in which it is there. So I will say number of moles of solvent say number of moles of solvent is ns. Here also number of moles of solvent, approximation because we are doing ns. So you can write here because the amount of ethane is negligible, hence number of moles of solvent same in both cases. So here mole fraction n by ns. Here mole fraction n dash by ns. I have neglected the number of moles of solute as compared to solvent. Otherwise, it would have been n plus ns here and n dash plus ns here. So I am doing approximation, so I am writing ns. Is that clear, everyone, or not?
Yes.
Vedant, is that clear or not?
Yes.
Okay. Now you need to substitute these values. Either you say partial pressure is proportional to the mole fraction, or you say partial pressure is equal to kh mole fraction. In both cases, it is same thing. Kh will get cancelled. If you say kh, it is there. So now what you will do? In this case, it will be P equals to KHX. In this case, it will be P dash equal to KHX dash. So from here, you will get P1 by P dash equal to X by X dash. So P by P dash equals to X by X dash. If you divide this equation by this equation, obviously you will be writing that. Dividing equation 1 by equation 2, you will get this equation divided by this equation. KH will get cancelled. So P by P dash equals to X by X dash. Now substitute the values. 1 divided by P dash equals to X. X is N divided by NS into, I'm writing into, okay. I will just write reciprocal of that. NS divided by N dash. NS will get cancelled. So NS will get cancelled and you will get P dash equals to N dash by N. What's happening? Something wrong here. N dash by N. Then you simplify this equation. That is P dash, it's simply 5 into 10 to the power minus 2 divided by 6.56 into 10 to the power minus 3. When you solve it, you will get 7.62 bar. All the steps are clear or not?
Yes, sir.
Good. Shivani, these steps are clear or not? Are you listening to me or not, Shivani? Okay, good. Next, what is meant by positive and negative deviation from Raoult's law, and how is the sign of delta H mixture related to positive and negative deviations from Raoult law? So first, simple thing, we are talking about what is positive deviation, what is negative deviation. So first I am talking about positive deviation. Okay. So when we say positive deviation, what happens? You have A interactions, you have B interactions. So this is, say, one liquid, this is another liquid. Both are volatile liquids in Raoult's law. And then when we mix, it is AB. Okay. So when we say it is a positive deviation, then in that case, the vapor pressure which will result, that will always be greater than the vapor pressure in normal case. So whatever were the vapor pressures here, the vapor pressure here will be greater. Okay, the positive deviation, and in the diagram we will show it like this is P1 naught, this is, say, P2 naught. So we will show it like that. Positive deviation will be something above. So the vapor pressure, you can remember by the diagram as well. So the vapor pressure green lines of the resulting solution will be greater. Why the vapor pressure is higher? Because the interaction here are weaker. So in positive deviation, the interactions here in the resulting solution, the interactions between the molecules are weaker. That's what we talked about in case of alcohol and water also. After interaction, hydrogen bonding is still there, but the interactions are weaker. That's why positive deviation. What is positive deviation? Higher vapor pressure. So that's why higher vapor pressure is there. If the interactions are weaker, it means A and B both can get evaporated easily. Both, this bond can be broken easily, and both A and B can get evaporated easily. Means at lower temperature, at the same temperature, higher evaporation will be there. If higher evaporation will be there, higher vapor pressure will be there. Positive deviation. Okay. Then we talk about, okay, in terms of partial pressure, I will say PA will be greater than PA and PA naught and XA, or you can say P1. And then PB will be greater than PB naught XB. Okay. And during the class also, someone asked that whether it will be for both or one. It will be for both. Okay. So that's why I have written for both component A and component B. So now tell me delta H of the mixture, positive deviation and negative deviation. Ariman and Pratham have already given me correct answer for delta H. So for positive deviation, what will be the delta H? Whether it will be delta H mixture will be greater than 0 or less than 0. I'm just giving you a hint. Suppose you don't know, suppose you don't remember, and you know that we are talking about positive deviation. We are talking about positive deviation, and we are talking about positive deviation. Here you have more vapor. Means more molecules have got vaporized. And if there is vaporization, you know there is some concept of latent heat. Now think in that term. It is now physics basically, not exactly chemistry. Physics I am talking about. You can give me answer. So what's happening? Remember what's happening. You are mixing A and you are mixing B. Then there is vaporization. Okay. Then there is vaporization. So here delta H will be what? It will take heat and then get converted to vapor, and there is higher vaporization. Is this concept applicable, and if it is applicable, how it is applicable?
So because in positive deviation, there is the mixture becomes more volatile, and hence there are greater number of vapors, and hence more vapor pressure. And so for conversion, so for the number of vapors to increase, there will be absorption of energy. Hence, the enthalpy is positive, and it will be the opposite case for negative deviation.
So can you please repeat that?
Okay, Shashwat, repeat it.
So since in positive deviation, the mixture becomes more volatile, and hence there is greater vapor pressure. So when the solution becomes more volatile, there will be more vapors, and hence the solution will absorb energy for the formation of these vapors. Thus, as we know that enthalpy is positive when energy is absorbed, so the delta H for the mixture will be positive, and so in negative deviation, it will give out energy, hence the delta H will be negative or less than 0.
Right. Correct. Similarly, for negative deviation, you will change this sign. PA will be less than
Sir?
PA not X. Yes.
Sir, if we answer in terms of negative deviation means maximum boiling point, can we say that when stronger bonds are broken, it becomes an exothermic reaction? A lot of energy is released.
Come again. I didn't get you. Come again.
Sir, if we assume the case of maximum boiling point means negative deviation, can we say that since the bond AB bond was stronger, so when it got broken, the reaction was
Remember,
exothermic?
when we talk about maximum boiling point, minimum boiling point, we talk about azeotropes. That is related to azeotropes, where we will be talking about that the ratio of the mole fractions in liquid phase and in vapor phase is same. Then in that case, we talk about maximum boiling point or minimum boiling point. Here we talk in terms of the force of interactions. An aqueous solution of 2% non-volatile solute exerts a pressure of 1.004 bar at the normal boiling point of the solvent. What is the molar mass of the solute? Read the question, and then I will explain. Try to understand these points. Now, if you have read the question, try to understand what I am saying. Okay. We are talking about when we mixed a non-volatile solute, but when the volatile solute is not mixed, then what will be the pressure? And that is all about this question. If you get that, then it is done. Then obviously it is pure water. And in that case, it will be 1 atm. So understand here, whatever is given here, this is when it is solution. Okay. So say it is P. P is given 1.004 bar. But in case of when there was nothing mixed, it was P naught, and P naught was 1 atm. And here, because we are talking in terms of bar, we will say 1.013 bar. P naught would have been like this. And now you can get the answer. Relative lowering in vapor pressure is P naught minus P equals divided by P naught equals to N2 by N1. Do you remember that? Just substitute the values. 1.013 minus 1.004 divided by 1.013 equals to N2. N2 will be, you have 2% non-volatile solute. It means the solute is 2 grams if solvent is 98 gram, because out of 100 gram, 2 gram will be non-volatile solute, 98 will be solvent. So W1 will be 98, W2 will be 2. So N2 will be this one divided by its molar mass, which is asked. So it will be W2 divided by M2, which is asked, and N1 will be 98, and here I am writing 2, okay, divided by molar mass of the is this water, not given, aqueous solution, okay, it is water. So it will be 18, means it will be 2 by M2 into 18 by 98. From here you will calculate M2. So M2 will be 2 into 18 by 98 into 1.013 divided by 0.009. When you solve this, you will get 41.35 grams per mole. Yes, Kasak, you were correct. 98 gram will be the solvent. Question is straightforward, relative lowering in vapor pressure, because initially you had pure water, then you mixed non-volatile solute, there will be lowering in vapor pressure, that formula you applied. And as I said, in most of the cases, if it is 2%, 3%, 5%, up to even 5%, you can neglect here N1 plus N2. Instead of N1 plus N2, you can write just N1. So you can use this formula. Next question. Heptane and octane form ideal solution at 373 Kelvin. The vapor pressure of the two liquid components are given. What will be the vapor pressure of the mixture of 26 grams of heptane and 35 grams of octane? Now remember, we don't talk in terms of grams. Anyway, you will need moles of these. So you will have to calculate moles. What is this information given here? This information will help you, and you know you just need to use one formula for this one, because the question is about the vapor pressure of the mixture. So it means we are talking about P total. Who will tell me the formula? Just unmute your mic and tell me the formula.
So may I tell?
Yes.
P1 naught plus P2 naught minus P1 naught into Chi2, or like, sir, we can interchange according
Right,
to one or.
but here in this case, it is just P1 plus P2. In this case, obviously that is the formula. But here in this case, because you know P1, you know P2, you can calculate X1, you can calculate X2. So you can directly use P total is P1 plus P2 actually. Obviously you write this formula because you write this one as P naught X1, P1 naught X1 plus P2 naught X2. And then you write here P1 naught X1 plus P2 naught. Here you write 1 minus X1. And that's why you get that formula. Okay. P1 naught, or you can say just you can take X1, P1 naught minus P2 naught. And then you can write X1 here plus P2 naught X1. Okay. So whichever way you write this formula, that formula you write when you have mole fraction of 1. Okay. So you can use mole fraction of 1 if you get, okay. Otherwise, if you calculate mole fraction of both, you can just use P1 plus P2. Is that clear what I'm saying or not, Pratham?
Yes, sir, I got it.
Okay. So you can just calculate the mole fraction of 1. And if you don't want to use P1 plus P2, obviously you are free to use that formula. No problem. Devyansh, yes, formula was correct. Okay. So basically you will write it as the P1, you will write as P1 naught X1, P2 you will write P2 naught X2. And when there is nothing mixed, these values are given. It means these values are actually P1 naught and P2 naught. So you will write P1 naught 105.2 into 10 to the power. If you don't even write this kilopascal as Pascal, you will get the answer in kilopascal. So you can write 105.2. It will be kilopascal. And then you will write X1. X1 will be the number of moles of 1. The number of moles of 1 will be, if I write X1, first I will have to calculate N1 number of moles. It will be given mass 26 grams divided by its molar mass. So molar mass of heptane means C7H16.
100.
How much it is? You have calculated?
Yes, 100.
100. So you have to calculate and then substitute it. And N2 will be 35 divided by molar mass of octane. Okay, molar mass of octane, you add 14 into it. Okay, why adding 14? Because CS2 will be extra. So 12 plus 2, so it will be 114. From here you will write X1. It will be N1 divided by N1 plus N2, and then you can calculate X2 as 1 minus X1. Okay, so you will get X1, you will get X2. Substitute those values here. And you will get the answer. The answer you will get when you solve this one, 73.43 kilopascal. I'm not doing everything. You have to do that. Remember, every question of NCERT you have to do yourself and upload it on the website. Next one, and I think this will be the last question today. We can't do beyond this. The vapor pressure of water is given at 300 K. Calculate vapor pressure of 1 molar solution of a non-volatile solute in it. Now remember, we are again talking about the depression in, lowering of vapor pressure. Relative lowering of vapor pressure we are talking about, because vapor pressure of water, pure water, is this much. Means P naught is given. P naught is 12.3 kilopascal. Okay. Calculate vapor pressure means P is to be calculated. Okay. P or P1 or PA. Sometimes P1 is written, sometimes PA is written. So whichever you want to write, P1 is to be calculated. And it is 1 molar solution. So if it is 1 molar solution, what it means? 1 molar solution, and pay attention everyone, means 1 mole of non-volatile solute in 1000 grams of water. 1 molar solution means 1 mole of non-volatile solute in 1000 grams of water, and 1000 grams of water, if I say, this thing will be equal to 1000 divided by 18, that is 55.56 moles.
And sir, the mole fraction will be 0.017.
Yes, correct. Good. So from here you can calculate the mole fraction of solute. Okay. So mole fraction of solute will be number of moles of solute divided by And obviously you can write it in approximation also, because it is just 1 mole and you have 55.56. You can do approximation, but still, so number of moles will be N2 divided by N1 plus N2, and N2 solute is 1 and N1 is 55.56 plus 1, so obviously 1.56.56. And when you solve it, you will get 0.0177. Okay. You even do not need to calculate it, because you can substitute it in the formula. And the formula is very simple. The formula is P naught minus P1 equals divided by P naught equals to N2 by N1, which I have written as X2 because I have not done the approximation. It is X2. P naught minus P1 is equal to P naught divided by P naught equals to X2. So substitute these values. So it will be 12.3 minus P1 divided by 12.3 equals to 0.0177. The only unknown is P1. So from here you will get P1 equals to, when you calculate, 12.08 kilopascal.